Okay, so this was not on your quiz. This is what will be on your test as part of 2-2, which is polynomial functions of higher degree. Remember all the twisting and turning, all that stuff? This is the end of it. So we're going to work our way backwards through this. So if it asks you to find the function where you're given the roots, then you're going to take your list of roots, you're going to put them behind x minus. So it will always change the sign of whatever's there. And then you'll simply multiply out the polynomial. So you'll FOIL it out. So an example would look something like this. Find the polynomial function that has the given zeros. So it would be x minus a -1, x minus 3, and x minus 4, which becomes x plus 1, x minus 3, and x minus 4. And then you're just going to FOIL them out. So 2 at a time. I'll start with these two. X squared minus 3x plus x minus 3, which becomes x squared minus 2x minus 3. And then don't forget to bring down the last one, x minus 4. And then I would, again, distribute. So I'd get x to the third minus 4x squared. I'd get negative 2x squared plus 8x. And then the last one, negative 3x plus 12. And then at the end, you're going to combine all your like terms. So x to the third minus 6x squared plus 5x plus 12. And you're going to set it equal to f of x. So don't forget that when you're finding a function, you need an equals f of x there, okay? So just change the signs, put them after the x, FOIL them out. Should be pretty easy stuff. Just be careful with your signs. Positive and negatives will be the death of you guys. Questions so far? So now obviously it gets more complicated. Now you've got two terms in that polynomial, in that individual answer. So if I were to write this out, I would say x minus this first term, which would be 3 plus root 2. And then it would be x, this is still a positive at the front, so minus 3 minus root 2. And then that negative goes to both. So this becomes x minus 3 minus root 2 and x minus 3 plus root 2. So be careful with your signs. If the leading number is negative, then, the leading number is positive like this one, then it's going to be minus at the front, but that minus has to get distributed into both terms. So now when I multiply it out, the x is going to go to all three. I get x squared minus 3x plus root 2x. The negative 3 goes to all three. Negative 3x plus 9 minus 3 root 2. And then the negative root 2 goes to all three. Negative root 2x plus 3 root 2 minus root 2 times root 2, which is what? 2. So now I get x squared. I have a negative 3x and negative 3x. So I get minus 6x. I have a positive root 2x and a negative root 2x. Those are going to cancel out. I have a positive 9 and a negative 2, positive 7. And then I have a positive or negative negative 3 root 2 and a positive 3 root 2. Those get canceled out as well. So I get f of x equals x squared minus 6x plus 7. So these are opposites, right? One's a plus and one's a minus in between. If that happens, your roots will always cancel out. So if it's the same expression, but one's a plus and one's a minus, your roots will always cancel out. So this says find the polynomial function with the leading coefficient 1 that has the given zeros, multiplicities, and degree. So kind of like pairs what we did with the changing with the graphs in with what we're doing. It says the 0 is 3 and the multiplicity is 1. What's that mean? There's only one 3, right? So that's going to be an x minus 3. Then it says the 0 is negative 2 and the multiplicity is 2. What's that mean? There's 2 of them. So it's going to be x plus 2 and x plus 2. And the degree is 3. What's the degree? Highest exponent. So once I multiply this out, my highest exponent should be to the 3rd power. So I'm going to multiply it out. I'm going to do these two first. X squared plus 2x minus 3x minus 6. X squared minus x minus 6. And then I'm going to bring this one down and multiply it out. X to the 3rd plus 2x squared minus x squared minus 2x minus 6x minus 12. X to the 3rd plus x squared minus 8x minus 12.
It doesn't matter if we do the x plus 2
Nope.
together.
Doesn't matter the order.
Also, why is are we doing that, like the x minus, what are we looking for?
You're working backwards, so I'm giving you the solutions, you're giving me the polynomial. So normally we would take the polynomial and factor it and solve it. Now we're working the opposite order. We're setting it up as an expression, and then we're factoring it out. Or foiling it out, sorry. So 2 things to check. One is it said that the leading coefficient is 1, which means the term with the highest exponent should have a 1 on the front, and this does. And then the other thing says that the degree is 3. We want to look at the highest exponent, which is 3. So you can confirm 2 things about it just by stating that. Ouch. Questions on that part?
Wait, I don't really understand the degree.
Degree is the highest exponent. So that's just your way of checking to make sure that what you've done is right, because it should be the highest exponent is 3.